Generative Artificial Intelligence, GenAI. Generative AI has taken worldwide storm. This is a visual depiction of generative AI called GenAI Prism, created by Brian Sellis using Jet3 design in collaboration with Connor Gannon. We can see here AI has already performed many complex tasks like summarizing text, conversational chat, image generation, conversion text to video, generating sound and music, analyzing, fixing, and generating code, and what not. Scientists have found early spark of artificial general intelligence (AGI) in GPT-4 model. Now, what is going behind this revolution? How this AI is different from other form of established branches of AI like supervised learning, reinforcement learning, classification, regression, etc. Let's look at generative AI, how it works at conceptual level. Then we'll dive into various generative model or families of models, and we'll try to relate it with human learning pattern or how human does generative work, and a lot of ideas being lifted from those concepts and brought into the context of artificial intelligence. In terms of generative AI, we need to contrast it with discriminative AI. Generative AI models share a common goal, and the goal is build a probabilistic model with emphasis on context so that it can model the underlying distribution. And what do we see in generative AI? The data could be labeled data or it can be unlabeled data at the time of training. Though it looks like unsupervised, but many call it self-supervised because in generative AI, models or AI is learning itself based on its interpretation and representation of data at very high dimensional place. Despite using different techniques, all these generative AI conceptually aim to model the underlying distribution of the data, create new instances that could have been drawn from the same distribution or the same model. Now, in contrast, discriminative model focus to build a decision boundary to separate each class, and all data is labeled data. Predominantly, this is supervised learning. Now, one toy example and explain this to behavior to reinforce these ideas. Suppose we have got few data points like here orange group of data and green group of data. Now in generative AI, what it will try to do, it will try to model all this orange data and green data. Whether we supply the level or no level, it will group them in a very high dimensional space, encode them, and create a latent space of underlying distribution. So it may be a model like this and could be another model like this. And we can see there could be always some overlap. Here we are showing only 2 dimensions, but in reality these are in very high dimension space. Now if we ask to generate a orange and green point, it will refer this model and give 2 new points. Now contrast this with discriminative model. Similarly, if we have orange and green data points, the model will try to create a boundary to separate this data point. Now next time when we get 2 new points and ask the question which class this data point belong to, it will check the boundary, and based on this boundary it will decide okay, this is green and this is orange. Now let's look at generative and discriminative model, how it works with toy example to solidify the concept. Generative model. Now generative model could be of 2 broader type. One is normal generative model and another is conditional generative model. So one example could be in normal model we are asking to generate face, and we have a model of all faces, which could be an animal face, it could be human face, it could be cat, dog, tiger, anything what model has built at the time of training. So when we request for a face, it will pick from this data and generate an image. So first image could be a cat image, another one could be a dog, Another one could be human face. Now, when we are putting a condition that generate human face, model will specifically focus on the area or the latent space where human face data is encoded, or the model is particularly focusing on human face related attributes, and it will generate a face and it will generate randomly a human face. If you request again another human face, and it will generate another one. Similarly, another one, all three would be usually different because we want some sort of noise and randomness in output. Now, compared to this, the discriminative model, the question that we are asking is quite different. In discriminative model, basically we are trying to do classification. So our question could be, is this a human face? So we'll supply an image and ask the question if this is a human face. Now again, as we have shown, there will be a model which has already trained with a lot of data on human face, say cat face, maybe tiger face, maybe some other face, and there is a decision boundary which has splitted all this data into different spaces. So when we request for to check if this image is a human face or not, it will compare this data and check where this data fit into that based on the decision boundary, and it will find that okay, it's similar to all the other human faces. The probability wise, it will be very similar, or it will be very high probability in terms of human face. And then it will give a response saying yes, this is a human face. There could be another image. It will check again the model and it will see, the probability wise, it doesn't look like a human face, and it will conclude it's not a human. So that's how generative and discriminative model work at very high level. Now let's take a look at human, how we learn, and how this generative AI is closely connected with all the ideas of learning and generating something that human does. We learn from examples since our childhood. We use our 5 senses to perceive the world, and then we learn from it. Many of these learning are self-learning, and some of the learnings are through feedback mechanism, where someone tells whether this is a cat or dog, or if you have given an exam, the teacher will provide feedback how well the essay we have written or how good the diagram we have drawn. So there is a continuous feedback mechanism. And based on all this input, we create a mental representation. We create our world of how to interpret things. We tag certain things like, okay, this is a number, this is an alphabet, this is how the world looks like. And we try to generalize things. So after seeing 3-4 pictures, we can understand that, okay, all these are animals. Yeah, this looks like a plant. This looks like a non-living thing. We also bring our imagination and creativity while creating some artwork or something. The brain uses its imagination and creativity. And there is always some kind of uncertainty and noise as well as randomness for whatever things we do. Not two things will be exactly same. There will be some kind of difference from person to person, as well as the same person at 2 different times. If something is newly created, it will be a little bit different. Now all these processes or input or learning that we do over our entire lifetime, generative AI perspective, all this can be compared with something called encoder. Basically, we are encoding all information, and while we are encoding, we are encoding in our brain, which is something similar to in generative AI called latent space transformation. So we are transforming all this data into a kind of latent space and storing this information. And the next stage is decoder, which takes data from that latent space and decode the data and present it as an output. Exactly same thing generative AI does. Most of the models follow this basic structure and concepts of encoder, latent space transformation, and decoder. There are various algorithms and models for building generative AI. Predominantly, we can categorize them into 7 categories: autoregressive models, transformer BERT or GPT based models. All these are some kind of autoregressive models, and these are closely related to this encoder-decoder model. Then we have variational autoencoders, generative adversarial networks. Generative Adversarial Networks, or GANs, were introduced by Ian Goodfellow and the team in 2014. This innovation revolutionized the field, and a lot of interest to create and generate artworks, speech, text, all this started after this paper was published. Normalizing flows, energy-based models, diffusion models. Diffusion models are behind all the amazing images that we are seeing in DALL-E 2 or Stable Diffusion. Then there is something called hybrid models, which are mixing up all these models or architecture to derive some generative models. Now, while encoder-decoder is the fundamental concept behind generative AI, there are various other mechanisms and variations available. We can see adversarial training mechanism, which is used by GANs. Some models are trained to predict the next pixel or next word or node in a sequence given the previous context. This is the foundational block for autoregressive models. Invertible transformations apply to a simple probability distribution like Gaussian. This kind of application we can see in normalizing flows. Energy function to model the relationship. So all energy-based models, EVMs, use this concept. Iteratively denoising a sample. This is the fundamental concept behind diffusion models. So all these models are learning from huge amount of training data. Some of them are using entire internet data to train the model. And it's bringing in concept like generalization through representation learning, multimodal relationship understanding, and build a latent space. So that's all for this video. Thank you so much.